Welcome, pre-calculus students. Today we're going to start by reviewing some basic things about angles, so it's kind of go a little bit quick, but things you should know. One way to think about an angle, and we are going to go over multiple ways of viewing them. One way to think about an angle is the joining of two rays at a common endpoint called the vertex. So if you take a ray starting at any point, extending out to infinity, take another ray starting at any point, extending out to infinity, that's one way to think about an angle. When we think about these angles, we're going to be referring to them as different names. That little fish-looking thing is an alpha. The B looks like a beta. The kind of hook, oh, that's a bad one. The kind of hook-looking thing, that's called gamma. The most popular is going to be theta. That's a little zero or an O with a line through it. Those are Greek letters. I don't know how they came in convention, but they're used. Two angles sum to 90 degrees are called complementary. Two angles that sum to 180 degrees are called supplementary. Neither of these should be surprising, nor should the next pieces of information. There's some different special angles in the properties. Just a quick review of these. Name an angle we're going to call a straight angle. Anytime our angle will start with alpha, we'll have degrees of 180. The sketch of this is just a straight line. In other words, they're 180 degrees in a straight angle. Not too surprising there. We call it a right angle when our degree, we'll go with beta this time, is equal to 90 degrees. In other words, if you were to make these rays into lines, those would be perpendicular. Oh, and that's our sketch. I'll just move that over there. Perpendicular is another way to say those two rays. When our angle is less than 90, so in this case we'll say theta is less than 90 degrees, it's called an acute angle. And anytime our theta is greater than 90 degrees, it's called obtuse. No surprises here, but just to make sure we're all on the same page. What may be new, maybe you haven't worked with these before, are different ways of measuring angles in a little bit more precise manner. For some degrees, you're going to see degrees, but then also minutes, and also seconds. Because these measurements are called degrees, minutes, seconds, you may also see as DMS. An example would look like something like 118 degrees, 32 minutes, and 34 seconds. This is the symbol for degrees. One dash means minutes. Two of them means seconds. This is another way instead of writing decimals. It's common in different practical problems. But minutes, there's just like in time, there are 60 minutes, and instead of 1 degree, or instead of 1 hour, now we're going to say in 1 degree. There's also 60 seconds in 1 minute. So what that means, just looking at the reciprocal, 1 second, let's start with minutes, it's a little easier. 1 minute will equal 1/60th of a degree. And 1 second then, if we multiply 1/60th by 1/60th, will equal 1/3600th of a degree. And we're going to use that information to help us convert between different measuring units, like we are going to do in the problems right now. So if we start with, we're going to convert 36.325 degrees into DMS, which means we're going to figure out how many degrees, we're going to figure out how many minutes, and we're going to figure out how many seconds this would be. Well, the degrees is the same. We're going to start with 36 degrees. What we're going to look at is this 0.325. If we take 0.325, we want to figure out how many seconds, just like if you would say how many minutes are in 0.325 hours. If you want to figure out how many minutes are in 0.325 degrees, we're going to multiply this by 60. When you multiply it by 60, you get 19.5 minutes, which means we can add 19 minutes to our DMS representation of this angle. And now we just got to once again look at the decimal. Well, how many seconds are in 19 minutes? Well, you're going to take 0.5 times 60. 0.5 times 60 would give you 30. So 36.325 degrees is the same thing as 36 degrees, 19 minutes, and 30 seconds. It's a similar idea to convert from degrees, minutes, seconds into decimal degrees. So if we take a look at 117 degrees, 29 minutes, and 56 seconds, we can add up various parts. And what I'm going to add is we're going to start by 117 degrees. We're not going to touch that. We're going to add 29 times, and since we said 1 minute equals 1/60th of a degree, to figure out how many minutes or how many decimals this would be, we're going to multiply by 1/60th. Dividing by 60 is going to do the same thing. For 56 seconds, we're going to add 56 times 1 over 3,600, because that's how many seconds, 1 second is 1/3,600th of a degree. When you divide and you multiply and you add all those up, you get 117 plus 0.4833 repeating plus 0.0155 repeating, which gives you a total of 117.4988 repeating degrees.